Okay, welcome to this YouTube lecture. So we are going to discuss about how to calculate limits of the indeterminate form 0 raised power 0. So we'll use this example to illustrate the steps. So solution. So limit as x approaches 0 from the right, x raised power x. When we replace 0, where this x, we get this 0 raised power 0 case. So what we do now, we say let y to be x raised power x. And then you remember that you can always write this one, introduce ln, and then write this one into a different form. So say ln of y equals to ln of x raised power x. And then using laws of logarithms, this is the same thing as saying x ln of x. So what you do now at this point, we have ln of y equals to x ln of x. So which means that then now e raised power ln of y is the same as e raised power x ln of x. And then remember, e raised power ln of y is the same as just y. So don't forget this property that e raised power ln of a is just a. So therefore, we are interested in finding the limit of this function x raised power x, which was, from the start, we have said that let it to be y. So therefore now, so call this one equation 1. So I'll take limit as x approaches 0 from the right on both sides of equation 1. So we'll have limit as x approaches 0 from the right of y, the same as limit as x approaches 0 from the right of e raised power ln of y, which is the same as limit as x raised power x approaches 0 from the right of e raised power x ln of x. And then remember this property that we enlisted when we were introducing L-Hospital's rule from the start, that limit not limit as x approaches a of e raised power y. Let me just use a general function. E raised power f of x is the same as e raised power limit as x approaches a of f of x. So it's the property that you are going to use. So from this one here, using this property, we'll have limit as x approaches 0 from the right of y will be e raised power limit as x approaches 0 from the right of x ln of x. So let's concentrate on getting limit as x approaches 0 from the right of x ln of x. Call this one equation 2. So this can be written as limit as x approaches 0 from the right of ln of x over 1 over x. By rewriting this one, this function x ln of x in this form, it will allow us to have the form when you replace 0, we'll have the case of infinity over infinity. So which will allow us to apply L'Hospital's rule. So this will be the same as limit as x approaches 0 from the positive side. When you differentiate ln of x, you get 1 over x. When you differentiate this one, you get negative 1 over x squared. Remember, 1 over x is the same as x raised to negative 1. So when you differentiate, it will be negative x minus 2, which is the same thing like this. And then this will be the same as limit as x approaches 0 from the right. So 1 over x divided by minus 1 over x squared is 1 over x times minus x squared, which is minus x. So this is minus x. And the direct substitution will be minus 0 is just 0. So from equation 2, we have limit as x approaches 0 from the right of y, which is ideally the same thing as limit as x approaches 0 from the right of x raised power x, because y is the same as x raised power x, is the same as e raised power limit as x, limit of x ln of x, which is the same as, we have found this limit to be 0. So therefore the answer is just 1. So the value of that limit is 1. So that is how we work out limits of the form 0 raised to 0. Thank you.